All right, in this video, we're going to look at number 3 from section 3.8, which is the final problem. And 3.8 only has 3 problems, but they're really good ones, as I'm sure you found out if you've gotten this far. And number 3 is going to do something a little different than the last two. And the difference is that you're going to have to come up with the formula yourself. In the last two problems, you were given a formula and you plugged stuff into it and you simplified it and you rearranged it and you did stuff like that. Here, we're starting from scratch. So hold on and I'll show you what I mean. All right, here's the situation. There's an organization with a logo, and that logo consists of 3 squares like you see here. And these are in fact perfect squares. And what they want you to do is to make a formula. And that formula is going to be A equals something. A stands for area. And that something over here is going to be the area of this square and this square and this square all put together. So it's one formula that's going to calculate one area that's the total of these 3 different squares. And furthermore, they want you to do it based on the length of the side of one of the squares. And here's what they mean by that. They mean that they only want you to have one unknown variable in here. And how is that possible, you ask? There's so many squares and so many sides. Well, let's think about a square for a minute. So typically, if you have a rectangle of any type, it's the length times the width gives you the area, right? Area equals length times width. But that would be for a rectangle, for example, if you had a rectangle like this, and it certainly is true on our square. But our square has something special going on that this rectangle here does not have going on, and that is that this side here and this side here are the same distance because it's a square. Okay, so we need to come up with some letter, and you could use S, or you could use W, or L, or anything you want to. Choose some letter to equal this length of this side here. And so why that helps you is because that tells you what this length is. And then you also have these other 2 squares here and here, which are identical to this first square here. So think about this a little bit, and you need to come up with one formula using one variable that gives you the total area of all 3 of these squares. All right, so that is your first job. All right, well, that was something a little different, making your own equation like that, making your own formula. And the good news is this next thing that they're having you do with this formula you made is something familiar. Okay, so check out and watch what I mean here. So they are telling us that we have approximately 1,500 square feet of material to make a really huge version of this logo. So what is 1,500 square feet exactly? Well, let's go back to that formula you just made. So remember that formula is going to be A equals something. And this something over here is going to have in it the length of one of the sides of the squares and then some other stuff. Okay? And so you already made this for part A, but I'm not going to ruin the suspense here by telling it to you. So what they're asking you here is that you have 1,500 square feet of area worth of material. So where is that 1,500 square feet going to go? Where is it going to go? Well, that's not talking about the length of the side of the square. In fact, they're asking us how long should we make each side of the square. So this variable down here, this S or whatever letter you chose, it really doesn't matter. That is the thing we don't know. And this A, this area, that's what they gave us. They told us the area is 1,500 square feet. So we look carefully and we see in our formula the area is taken care of by that A over there. So we're going to plug that in, and we're going to do stuff backwards to find what the length of the square is. And let me give you another hint here. All right, so this may look familiar to you, and if it does, that's all right, because this was taken, we looked at this exact example back in section 3.4. If you recall this, we had a cylinder. We looked at a cylinder, and we looked at the formula for finding the volume of a cylinder. And in this case, we simplified the formula. Remember doing that? And said, well, what if the height is 11 of all the cylinders I'm concerned about? Let me simplify that formula. And that's what we did. We plugged in the 11. We plugged in an approximation for pi. And that is the formula we got right there. That's our simplified formula. And then we took that a step farther and said, okay, let's suppose we're given the volume of this cylinder. We're given the volume. We're told what the answer is. So we plug that in over here for the V. And then we have to work backwards and find out what is our radius. And so what we did is we divided by 34.56, and then we ended up with this little equation down here. 100 equals r squared, and we had to figure out to determine what r is. And so r squared means r times r. So your first thought might be, well, the opposite of that is dividing by r. But that wouldn't help us really, because then we'd have two r's, one on each side. So we needed to figure out something to undo r squared. And in this case, we were able just to look at it and intuitively realize, well, what number times itself is 10? Well, is 100 rather. Well, 10 times itself is 100. So that's how we knew what r was. So what's the operation that we used to go from this upper step to this lower step right here? So this operation that undoes this r squared, hopefully you were able to use this operation back in section 3.4 to answer the braking distance question, where it asks, how fast would you have been going in order to stop in 100 feet or whatever it was. But let me just kind of go back over that real quick to make sure that we still have it. So what is the operation that gets me from here to here? What's the opposite of squaring? Well, if you recall, we talked about that guy right there. That guy right there. And that is the square root. So if I have 100 equals r squared, I could just throw one of those guys up on each side. And these two things cancel. And what's left is that my r is the square root of 100. And you probably have a key on your calculator that has this. You certainly need that key when you have numbers that aren't as nice as that 100. But with the 100, we know this asks the question, this radical sign asks the question, what number times itself gives you the thing under the radical? And we know this to be, we know that the square root of 100 is 10, so my r is equal to 10. So this little guy here will probably help you, just a hint, on number 3 in section 3.8.